and welcome to this online revision session for AQA FP3, which we're looking at the June 2011 question 3 on improper integrals and their evaluation. You can see this question comes in three parts. The first part, we have to evaluate this integral, which we should recognise as a product, so we need to use integration by parts in order to integrate this function. Then we have to explain why between 0 and e this would be an improper integral. And then in part 3 we have to evaluate that integral using the limiting process. So first part, integration by parts. You should know for the two parts you label one part u and one part dv by dx. Since you only know how to differentiate ln x, the sensible thing to do is to let u equal ln x and then let dv by dx be equal to x squared. Then you can say that du by dx is equal to 1 over x, differential of ln x, and v will be equal to x cubed over 3. So if I call this integral I can now say that I, using integration by parts, is equal to uv, so that's 1/3 of x cubed ln x minus the integral, well, it's going to be the integral of 1 over x times x cubed over 3, that's v du by dx, which is going to give you x squared over 3 dx. And of course this x squared over 3 is now something that you can actually integrate. So we now get 1/3 x cubed ln x minus, well, the integral of x squared is x cubed over 3 and it's already over 3, so that will give us x cubed over 9 plus your constant. Okay, well, it's 3 marks for doing this, so again a mark for realising what you've got to do and getting it down to a form that you can actually integrate, and getting it to that form accurately will give you 1 mark extra, and then performing the integration to complete the process will give you your 3rd mark. In part B we have to say why this is an improper integral. Well, it can be an improper integral if the limits create an infinite range. Well, in this case from 0 to e is not an infinite range, so therefore the problem must be to do with the definition of the function at some particular point within the range from 0 to e, and the key problem is that, of course, that ln of 0 is not defined, and so what we need to say to get your 1 mark is ln of 0 is not defined within at the point where x equals 0. Okay, and that will give you your 1 mark. Finally, we've got to integrate this function between these two limits, 0 to e. So 0 is our problem, so to evaluate this integral we're going to have to give it a change, so we're going to have to do the limit as a tends to 0 of the integral from a to e, a to e of x squared ln x dx, and we know, because we've just worked it out, that this becomes the limit of a to 0 of x cubed over 3 ln x minus x cubed over 9 between a and e. So substituting in our values, we get the limit as a tends to 0 of, putting e in, we get e cubed over 3 ln of e minus e cubed over 9, and then substituting a in, remember this is minus all of this, we're going to get a cubed over 3 ln of a minus a cubed over 9. So the first two terms here are just values that we can work out. The key thing we then need to look at is what happens to a cubed over 3 ln a and a cubed over 9. Well, the a cubed over 9 is fairly obvious that as a tends to 0, this will disappear. Then the a cubed over 3 ln a, that is one of our cases that we know that the limit as x tends to 0 of x to the k ln x is 0 when k is positive. K is 3 in this case, so this will also tend towards 0. So both of these terms will disappear. So all we are left with is going to be the two constant terms. Well, we know that ln of e is 1, because that's the base of the natural log. So all we've got is e to the power of 3, a third of it minus a ninth of it. Well, a third minus a ninth, well, a third is 3/9 minus the ninth gives us 2/9 of e cubed. Okay, well, 3 marks again for this part, for realising then we had to take a limit as a tends to 0 and coming up with the appropriate expression that we've got to consider the limit for. We'll get 1 mark. But then at some point stating what happens to each of these two functions here, that will give you a mark, and then obviously an accuracy mark at the end for having the correct limit at the end of that process. Well, hopefully you found the solution to that question helpful. For more solutions and help with your revision, please go to the Further Maths Support Programme website.